In school, we learn about classical physics. We play around with Newton's laws and believe that that's that. That's all there is to our world. However, it's really not that simple. It's more accurate to consider our world as having two parts. What we live in, know, and directly experience, that's the macroscopic world. Meanwhile, the subatomic world, that's explained by quantum physics. The two even overlap at times, but strictly speaking, they just apply to their respective distinct systems. The classical system is easily measurable. Objects have a definite mass, position, and momentum. Use a meter tape, scale, stopwatch. You can throw a ball and get its position before and after the throw, the momentum at which you threw it, and if you're a good shot and it lands on a scale, you'll even get its mass, all in one go. Now, for the smaller things, and this is a topic we'll come back to, we just can't. We cannot measure both the position and momentum of a quantum particle due to a concept called Heisenberg's uncertainty principle. It's all starting to get blurry, isn't it? Well, it's because of the wave-particle duality, and that means we have double the equations to deal with but half the clarity. And how is it possible for something to be both at the same time? And hey, what's that box doing there? Should we open it? I'm taking bets, ladies and gentlemen, that there's a not quite dead, not quite alive cat waiting in there. Can a cat be both alive and dead at the same time? Does everything around us have a wavelength? Can particles just pass through a medium with no issues whatsoever? Does gravity even exist in quantum? It has to, right? Is E equals mc squared more than just a catchphrase? Yes, but how about we find out where it really comes from? And these are all just the tip of the iceberg of what I'll be trying to explain. It's complex and sometimes it might seem messy, but despite it all, physics is, in its own way, logic. This dive into the quantum world will take place in 4 separate parts, this one not included. First, we'll go over what quantum physics is and how we know that it's real. After that, we'll go over the main quantum principles and then take a detour to talk about gravity in the subatomic world before returning to the quantum applications in our world. We'll cover the big stuff, get to the smaller parts, and mention all the big names. If this sounds interesting, be it new or familiar concepts, I hope to see you back here again as we dive into the world of quantum. Starting off with, how do we know that quantum physics is real?